Hello everyone, welcome to Mind Maps in this polarographic series. In these polarography lectures, we are continuing with the process of polarography. We are discussing Ilkovic equation. So, how does it arise? If you see in the previous videos, we talked about diffusion current and how it was proportional to the value of k. So, now this k is not a singular term, it is a collection of these terms basically, right? This long equation, and then we have the concentration of the analyte, right? So this is an equation, it is known as the Ilkovic equation. Proportionality constant k is a collection of terms which are real constant, and hence some of them must be controlled. We can control these to achieve linearity and proportionality. Like these should be reproducible, that's why there's a constant, right? It should not keep changing. Now id is the average diffusion current, and it is measured at a temperature of 25 degrees Celsius. So we are keeping all the conditions constant. So when we measure diffusion current at 25 degrees Celsius, we have an additional constant, that is just a real number, 607. This is the value at 25 degrees Celsius. This is an additional term that is observed. What is id? Id is average diffusion current. This is measured in microamperes. We should keep the units in mind. What is n? N is the number of electrons. Suppose we have Cd plus 2, the value of n is 2, right? This has no unit. So we are discussing this equation. Later on we'll be discussing the numericals. So n was the number of electrons that were involved in the process. So when there is Cd plus 2, we have 2 electrons, so we'll simply put the value 2. Now d, what is d? D is measured in centimeter square per second. What is d? It is the diffusion coefficient. This is the diffusion coefficient, right? D is the diffusion coefficient. It is a measurement of how species diffuse. What is the rate at which the species diffuse under the influence of standard concentration gradient. What is m? The next part is m. It is the mass of mercury forming through the capillary per unit time. So we have a capillary, right? It has a mercury, it is dropping, right? So what mass is falling into the solution, right? This is mg per second. This is the mass of mercury falling per second or per unit time. What is T? T is the drop type. This is measured in seconds. And finally we have the concentration terms. But the important thing that we need to keep in mind here is, what is that? This is millimole. The concentration term is measured in millimole per liter, right? Millimole per liter. So that is something that we need to keep in mind. Now there are two terms that can be combined. The m to the power 2 by 3 and t to the power 1 by 6 can be combined together as another constant that is known as capillary characteristic. This is particular to a particular capillary, unique to a particular capillary, right? So this is capillary characteristics when we combine these two, right? we can form another constant, that is capillary characteristics. Finally, if we look at the equation, id is equal to K into C. C is in millimole per liter. So this was the Ilkovic equation. I hope you liked this lecture. Thank you.